Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the editorial director with Data Science Central and also chief data scientist for Data Magnum. Now, I'd like to start off our event today by thanking Trifacta and DataRobot for sponsoring today's event. Trifacta and DataRobot are both longtime supporters of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, today's webinar is entitled Data Prep and Automated Machine Learning, Better Predictions for Consensus. And that'll be presented jointly by Trifacta and DataRobot. But before we begin, I'd like to briefly review the format for today's webinar. Today's event will be an hour long. We have three presenters who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation. And today's event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speakers, David McNamara with Trifacta, Harrison Lynch with Consensus Corporation, and Rajiv Shah with DataRobot. Now, David is a lead product specialist at Trifacta. He has 3 years of wrangling expertise at Trifacta, working on solutions to use cases including healthcare, supply chain, media optimization, and marketing analytics. Now, Harrison is the Senior Director of Product Management for the Consensus Marketplace Cloud and Risk Cloud products. Ever the digital sheriff, he keeps himself awake at night pondering how to prevent identity thieves from stealing iPhones and how to manage multiple product managers and dev teams. Harrison spent the last 15 years in the world of integrating cell phone carrier systems to web applications while trying to stop fraudsters. He loves a good nerd fight and has never seen a product management blog that he won't dive into. Harrison's a 1995 graduate of the University of Oregon. Now, Rajiv is a data scientist at DataRobot, where his primary focus is helping customers implement AI for better decisions. Now, previously, Rajiv was part of the data science teams at Caterpillar and State Farm. He has a PhD from the University of Illinois at Urbana-Champaign. So David, Harrison, Rajiv, hey, thank you for being with us today. We're looking forward to your presentation. Now, finance smartphones are a magnet for identity theft, leaving retailers in the digital and telecommunications industry vulnerable to fraud. Consensus, a Target-owned subsidiary, has developed a highly accurate solution to identify fraud at the point of sale before it happens. So in today's Data Science Central webinar, you'll learn how Consensus put together agile processes on a cloud analytics solution, leveraging Trifacta data prep and DataRobot automated machine learning to prevent fraud. So during the webinar, you'll learn how Consensus developed an AWS cloud-based solution, the role of data prep in supplying accurate data for machine learning models, how automated machine learning can drive more accurate predictions, and Consensus's time savings ROI for building models, deploying them on AWS, and improving in accuracy and recall. So David, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
All right, thank you, Bill, and hi, everyone. Welcome to this joint customer webinar with Consensus. We'll be highlighting the successful integration of Trifacta and DataRobot in Consensus's quest to detect fraud and curb fraud using machine learning. Quick recap of the agenda. This webinar will discuss the importance of data preparation to machine learning and how Trifacta and DataRobot solve two important pieces of the AI puzzle: preparing raw, disparate data into clean, actionable data, and automating world-class algorithms to gain insights from that data. This will be capped off with a discussion of machine learning business adoption at Consensus and a demo of Trifacta and DataRobot given by Harrison. My name is David McNamara. I'm on the product marketing team here at Trifacta. I'm excited to be presenting alongside Rajiv from DataRobot and Harrison Lynch from Consensus. Okay, so a typical organization's ML pipeline might look as follows. Raw data from various platforms enters the design process, where the data is prepared and then trained on the machine learning models. Following the design, data moves into an operational state where the models are scored and monitored, which can then lead to actionable insights that the organization derives its value from. A major bottleneck in this process can be the time it takes to prepare data for machine learning models, which is where Trifacta comes into the equation and will be my focus for the next few slides. By now, you may have heard the following quote in some form or another. There's the joke that 80% of data science is cleaning the data, and 20% is complaining about cleaning the data. 80% is well recognized as the percentage of time dedicated to data preparation. It's often a monumental task to take raw data from relational sources, spreadsheets, log files, sensor data, web applications, you name it, and clean it, blend it, and prepare it for machine learning. The process can be cumbersome, requiring multiple tools or processes to ensure that the data has been blended and cleaned and matches the organization's data quality requirements. The upkeep and maintenance of these processes on legacy platforms requires specific technical skills, which often create a bottleneck between business groups and IT teams. Trifacta's modern approach to data preparation solves this bottleneck by enabling data scientists and other data professionals to prepare disparate sources of data at scale, providing visual guidance and built-in machine learning to give visibility and validation of data quality at every step of the way. Trifacta allows you to quickly discover the contents, distributions, and quality of your data, giving you clear insight into the attributes that need cleaning or restructuring. Real-time previews and guided step creation allow you to preview steps before adding, eliminating the cycle of running code and then debugging when there are errors, which I'm sure a lot of you are familiar with. In connecting to various platforms from relational sources, big data storage platforms, cloud platforms, applications, and local data, Trifacta allows blending of disparate sources. And the intelligence built into the join interface means that you never have to guess which columns relate between sources, which can be especially useful when starting a new project. Additional validation steps at the end of your preparation cycle allow you to give one final check before sending off to your machine learning models. And quality data then feeds machine learning models like those curated through DataRobot's platform. By empowering engineers, scientists, and analysts alike to rapidly discover, clean, blend, and assess their data, Trifacta reduces the bottleneck and overhead of the data preparation process. Recognized as the leader in data preparation from the major media and analyst firms, we have over 85 technology partners, including our co-host, DataRobot. We have users from over 10,000 companies and are the enterprise standard for over 100 of the largest companies in the world. You'll get a glimpse of both Trifacta and DataRobot later in this webinar, as Harrison from Consensus gives a demo of both platforms. But first, I'm excited to pass the ball to Rajiv to tell you more about DataRobot.
Thank you. So what I'd like to do now is just give you a little bit of an introduction to DataRobot. First, let's start with the company, and then I'll go into the problem that DataRobot solves. DataRobot was founded in 2012. Its mission has always been automating machine learning. We're a well-funded company with a core of data scientists at its heart. Our mission has been to be about automating data science. Now, the problem we're solving is organizations are recognizing the value of data science or machine learning, that they can use data science and machine learning to solve problems, whether today it's fraud, could be churn, predictive maintenance. However, there's just not enough folks out there to help them perform that data science. And this is where DataRobot steps in. DataRobot helps out two personas in your organizations with data science. The first is your current data scientists. It helps them become automation first and take the power of automation to be able to increase their productivity dramatically. The second is, as you'll see today, with its friendly interface, it allows subject matter experts, business analysts, to now start building machine learning models. The result of this is, instead of the traditional way of relying on maybe one data scientist or trying to recruit and keep an army of data scientists, is now we can empower those data scientists with automation. We can also take advantage of other folks within your organization to be able to scale data science. Thank you. And now, Harrison, would you?
Thanks, Rajiv. Thanks, Dave. Let me take over. All right, so this is me. I've been at Consensus in a couple different roles since 2003, and have been dealing with mobile phone fraud probably since only a couple years after that, say 2005. So this challenge has been a passion for me for a number of years, and I've been exploring different ways to attack it. So what's Consensus? Very quickly, Consensus is a API aggregator specifically around selling what we would call connected products. So mobile phones being the most simple and easy to understand example. You have to buy hardware along with a subscription that requires qualification as well as activating service for it. But actually our platform can sell any variety of products like that. So whether it be gaming, whether it be a set-top box, a music subscription with a speaker, our platform is built to handle all those things. And generally in each of those there will be a case where there's risk involved to the retailer in handing over hardware that's worth quite a bit of money to somebody with the expectation that they're going to receive a commission down the road. So that's where the two products fit together, our integration platform as well as our risk platform. And then from the retailer's perspective, the value is also that we create a unified UI or an API suite to allow for a unified UI for easy training on the part of retail reps. So diving into the wireless fraud issue, let me quickly bring everybody up to speed on what's wireless econ 101. So your COGS, or cost of goods sold, for a phone is more or less $850. We'll use that as a center point. Obviously, if it's an iPhone XS, it can be much more. Some are less. The customer generally finances about 100% of the purchase. They can put a down payment down if they wish, but for simplicity's sake, and the classic purchase right now is someone pays $0 down. The carrier pays a device cost subsidy for that purchase back to the retailer when they've passed credit, obviously, and the entire transaction is activated. In addition to that, the carrier pays a commission to the retailer, and that's where the retailer makes a bit of profit. That number can vary depending on both the type of purchase as well as a number of other factors, who the carrier is, et cetera. For ease of discussion, let's just call that $100 to be easy. And in addition, the retailer also makes their money in revenue on warranty and accessories. If the sale goes bad, and it's at the discretion of the carrier, they can take back the commission and the device subsidy if they determine it to be fraud or other types of behavior. Then they may or may not take it back if it turns out to be somebody who just can't pay the bill. But in any case, the retailer is at risk in this transaction for a number of months after the sale, and it can be taken back. So one bad sale can wipe out the profit of up to 10 good sales. And again, that can vary by carrier, by purchase, et cetera. Okay. So as part of why we had to build this in the first place, and anybody in this business, is credit scoring obviously is not the same as risk prediction. Credit scoring is regulated and has a heavy regulatory oversight over it, involving your credit history, and it's really trying to figure out if this person is likely to pay on time. However, if you're an identity thief, that's the type of identities you are most trying to steal. So we need to find out whether this person is who they say they are, or whether they have an intent to ever pay, as in, is this purchase of positive intent? And that brings into frame a couple different types of fraud that happen and how we kind of segment these. There's identity theft, which is somebody steals your identity, either goes in and opens a new account under your name, or they steal your identity and your account info and they impersonate you and steal your upgrades or add lines to your account. In addition, there's a type of fraud known as credit muling, which is somebody goes in with no intent of ever paying the bill, buys the phones, and then sells them on the third-party market. This can often involve various forms of other fraud. People may do this unwittingly, etc. It's a pretty nasty form of fraud as well. So in our effort to stop this, we named this system Monks, and because we felt like the fraudsters are cobras. So Ricky Tikki Tavi was the inspiration for the name, and this is what it looks like. This is basically an entire system built to utilize machine learning to stop fraud. Orders enter our system. They are parsed by the API at step 2. At step 3, we have a data pipeline that then explodes the data and reformats it into what is necessary for the model to interpret it. And then at step 4, the model scores the extracted and reformatted order and gives you basically a numerical number that your system then uses to classify whether it should move forward with the sale or not. At step 5, as that's happening, we carve out a certain number of orders to create a control group. This is how we build future models, and that keeps the model honest. We also have at step 6 a rule engine that allows you to do additional things to orders. Some that pass, you may decide for other reasons that you can't yet fold into the model, you want to divert the orders. There are some other ones that you may decide you want to let the order move forward. And then we have additional functions that can invoke a third-party service, allow for a manual review to happen of the order, and in all cases we return an approve or decline in less than half a second. So from the point of view of the person standing in store trying to place this order, or the rep trying to make the sale, this is nearly seamless, and they get an answer back nearly in the blink of an eye. However, to do any of this in addition to the software engineering necessary, there's a step 0 that's required, and that's you have to prep your data, build and test a model, configure your data pipeline, and deploy it. And that's where what we're going to demo today comes into play. So data prep to model deployment basically follows this simplified path here. You acquire data. In our case, it's mostly from our internal systems. You have to prep it. You have to build a model. You evaluate that model. In addition, you have to evaluate what the necessary data formats do to your data pipeline, what changes you need to make there, and what sort of performance trade-offs you might make. When you have a model candidate and the accompanying pipeline updates that meet your needs, you then deploy it. So fairly straightforward. So where does DataRobot and Trifacta fit in? Well, they fit into this space here. Trifacta takes some of the load off of your data prep processes and really enables that function to happen much more quickly and with a broader range of people. DataRobot takes care of the model building, the model evaluation, and deployment steps. So what this does, sorry, I'm jumping ahead. So what this does is really enables your team to attack this problem with a broader range of folks than traditionally in data science. So some of the challenges we face in data prep are the data's messy. So we can get date formats that shift around. You can get inconsistent data types. You can get shifts in logic from different partners who we get the data from. So remember, a lot of our data comes also from carriers who give us back both reason codes as well as activity on account and different activity histories. the data can be in different places, and I also refer to this as sometimes toxic. So there's a decent amount of personally identifiable information in this data, also known as PII. So in many cases, you're not allowed to use that data directly. You have to create a hash of it, and it's, it can be somewhat black box. So you end up having to have someone create a script, hand it off to a team to create. Then they give you back a data set with a an order ID as a join key, and then you need to use that into your data prep and later your modeling. The other piece here is that I term this, you want to be able to scale your discovery, and that's where you want to be able to bring more domain and business experts into the conversation and into the building process than limited to only data engineers and data scientists. And so you want to be able to act on your hunches, and you want to be able to understand that ground truth of what's going on in your business, and then what is the data telling you about it that you may not have intuited, and vice versa. And last but not least, you want to be able to track your changes. So there's nothing worse than coming up with an end model that is very promising, and then you can't quite follow the steps of how it got there. And within this, there's a concept of what they call data provenance, which is ensuring that your data path along the way, you can maintain sort of a chain of custody. In model iterating, your problems are, the standard tools are what I would call learn, retain, heavy. So learning scikit-learn, or R, adds a bit of a learning curve, and maintaining it can be tough as well. You have to use it with a decent amount of repetition, otherwise you have to remember how to do it again and go through a few steps. Each model also requires a learning curve to remember how you need to set up your data, as well as the tricks to using it. And then your data pipelines need to be optimized to that model, which spawns off a set of software engineering every time you're making these changes. And you need your model and pipeline, they have to be optimized together, and what you really require is that that conversation is happening holistically. And then last but not least, what I'd refer to is user experience and data collection and the model need to be talked about holistically as well. And so what often happens without having the right folks working on this together is you can come to an outcome that seems very intuitive numerically, but the customer experience has never been considered. And oftentimes it can lead you down an erroneous road where you're starting to work on something as a solve, and then at the last minute you realize this is going to have a very negative impact, and you've wasted resources and time. Using these tools, as I said, allows you to bring folks into that conversation sooner. And the last piece is that this fosters what I feel like are not just our product goals, but basically anybody running a product team organization. You want to encourage and foster discussion among everybody involved in attacking the problem. You want to avoid silos. You want to move the conversation to the user experience as soon as possible, and basically ensure that you are at least staying neutral, if not improving that experience every step along the way. And last but not least, you want to bring together passionate, smart people and then turn them loose and get them working. So that's what I feel like our tools we're showing here have allowed for. So what that does is, using Trifacta and DataRobot, in our view, has allowed us to harness what they do very, very well and what they are improving, and allows us to focus on these two red zones, which are what our business domain and RIP truly are. Almost, I think anybody in this game, unless you're building competitor products in data prep or model building, really around knowing your own data, understanding your business, how you acquire data, and certainly some of the prep, as well as your data pipeline. And that's really where your engineering needs to be focused, is how do you keep that robust and quick. Okay. And then for a quick reference architecture here, this is basically how Trifacta and DataRobot are set up in AWS. So first step here, I'm going to show off how Trifacta data prep works. So let me toggle back to, so this is a set of files I brought in and then joined together. So as you can see here, when you bring a file into Trifacta, you get an overview of the data, how it's assembled.
Harrison,
as well as...
Harrison, excuse me, it's Bill.
Sure.
We can't yet see your screen. Would you try to do that screen share again?
I went too quick. Thank you. Okay.
Yep, looks good.
Thank you. Thank you. So you get a preview of the data, how it's assembled for each one. And but the real process starts when you move into bringing them together or writing what are called recipes. So first step I did here was I cleaned the dates. And this is where Trifacta provides me with immense productivity gains. And I you know, either myself or folks on my team, you don't have enough time to be ingrained in code or possibly remembering every SQL step along the way. So very easily, I was able to clean the date here, and Trifacta is able to recognize it as a date. So one way that you can see this is you can back this back up to when you have your recipes spelled out. And you can see it started out as recognizing it as a 2117. And then I was able to set the column type to I wanted it a year, month, and so on and so forth. And Trifacta just does these steps automatically. And so then I was able to merge these pieces together into a new order date time column and then drop the column that was left. So when I come back here, what I then did there was, and that was because the date column in this order file A was of a different format. And what had happened there was someone who had been working with it previously had opened it in Excel, and even though they resaved it in CSV, it changed the date format. So now you jump into merge these two together. And now we have a recipe that looks like this. So it's creating a union of the two files together and then changing the date to a string. And I think I was playing with this earlier, so I need to update the union step. So this is what a union function looks like. And what it does is it will bring the two together, and Trifacta recognizes each of the columns and matches them up as best possible. And then for this last one here, I need to bring it in because it wasn't an exact match. So by clicking this and typing that, it will bring it in, and now it adds it to the recipe. It's applying what it calls a union, and a union is when you're merging two data sets together as opposed to a join. And then I changed the date to a string. And then for our last one, I come here, and while it's loading a data set, we now have one that looks like this. So this is one where then I can go through at every step, and I can make a number of alterations to the data, creating an output that works perfectly for DataRobot. So one key thing I did here was I changed a number of these columns to be yes/no binaries, and that's because DataRobot performs very well when it's interpreting binaries. I also created the date columns, changed some names, and so on and so forth. And the great thing here is it keeps track in this recipe of every step you've done. So what that allows you to do is share these recipes over with another a coworker, and they can have oversight over what you did and recreate it themselves, which I think is key, is that you get that sort of scientific repeatability. So with that in place, you then have something that looks like this, and then you can run the entire recipe and create a data file, and that's what I'll do here. So you run the job, and it tells me here there's running. It's giving it that name, and I'll have it run it. And then it gives you an update here of how that's going. and it'll start, and when it's finished, then you have a chance to download it. So what I'm going to do is I'm going to jump over to DataRobot now and show you what that looks like when that's all finished. So for DataRobot, to create a new model set, you come here, you say create new, and from a local file, you can come in and you can bring in the any CSV data set. So you click it here, you click open, and DataRobot will begin importing it. And you can control right here the number of workers that are working on this. So right now it's uploading the data. So while it's doing that, I'm going to toggle over and show you what one looks like that's already finished. So this is the demo one I'm in, and it will give you it'll give me a view of the different data fields and how DataRobot has interpreted it. So let's toggle back and see how this is doing. It's got a bit of time to go. So, so the next thing it'll do is once you've kicked it off, it'll begin building models for you. And it'll go through an entire holdout and validation step automatically and start building models from the bottom up. And you can toggle over here what metric is most relevant to you. So I tend to focus on the AUC, but there's a whole variety here that you can look at, from log loss to Gini norm. So as it runs through these, it's building and selecting different models that it finds most interesting and building on those bit by bit. So in our case, our initial models we went live with were the logistic regressions, and they were pretty good, and they've done a good job in our system. But we knew we wanted to explore other models. We knew that they could tend to be more effective for us, more precise, lower false positives. And that's a key piece, is that in our business is beyond the financial benefits, a false positive is a terrible guest experience. And you want to try to minimize those as most possible. So we were really searching for that. So as you can see, it'll climb through and test different models along the way. We're getting there. And it creates a leaderboard from it, so it just tells you how each one is doing. And sadly enough, my favorite, the Valpole Wabbit, never wins. But in the end, you just can run through this and find out which one looks the best. And this is one benefit alone, which we found hugely powerful. So the idea of having a data science team go through and build this many models would be somewhat crazy. And even trying to shrink it down to a lesser number of models involves you making either educated guesses or trade-offs that may not be warranted at that time. So having this ability to run through a massive set of models and then come out with a numerical evaluation of each one really, I'd say, gives you a leap forward in how you think about solving these problems. In addition to that, DataRobot also supports these ensemble or blender models, which was an area that we had been exploring that we might go because different models are suited to different subcases of sales we make. So what we found in some experimentation is that while an LR is great for certain types of transactions, sometimes a random forest was better. Sometimes a Gini boost was better for other ones. And we were contemplating a road that would have branching and maintaining these multiple models at different stages. When you think about that, that's another scaling problem you run into, which is that you now have n number of processes for evaluating, retraining, and deploying a model for every one you're trying to do, and it puts a huge burden on your organization. So having the ability for DataRobot to build ensemble models for you really helps you jump that forward. And it does a nice job of showing you here what it's doing. It's doing some pre-processing, and I've lost my connection here. Sorry. Let me try reconnecting. Okay, well that's happening. Let me jump back. I'm going to jump forward to the next piece. So that said, another piece of our business that we do is evaluating third-party data sources to help also fight fraud. And we'll have a number of vendors coming our way that say, hey, I've got an additional way of evaluating orders for you that will help you stop fraud. And that can be things like they have their own proprietary social graph lookups to understand, say, is somebody who's been added to account actually related to or a friend of somebody who owns the account, or understanding the likelihood that if this account is being opened that seems possible. So they usually come in and what you're trying to figure out is how can I evaluate whether this will work for me in production, as well as what's its value to me. So one of the great things here that we love about Trifacta is that this allows me to add this data set in very easily. So what I've got here is a copy of my previous recipe, and then I brought in 2 additional data sources that a vendor might have given me. It has 3 fields in it. And I've joined them together here, and then I've added them to this recipe. And simply all I've done here is what's called a join function. And so we'll give that a moment to load. And I'll toggle back here. So reattach the DataRobot. So this is what the Blender had kicked out. So it's basically pre-processing the data in 3 ways.
This is Bill.
Yep.
We're still stuck on your previous screen share. Why don't you try stopping that screen share and restarting it?
Sure.
Up with where you are.
Okay. Looking better, Bill?
Yes, go ahead. Move your mouse and, yeah, okay, good. We're live. Thank you.
Great, thank you, Bill. So when you have these models built, then it allows you to come in and DataRobot gives you a full perspective on how effective the model is. So you have a lift chart here. What I find most compelling are the ROC curves and your payoff matrix, of course, which really show you how this model performs. And so you can click through each model here in the set and understand each one, how they perform against each other, and start to calculate which one works the best for you. So coming back to the Blender model and looking at the ROC curve, so you can see here would be my true negatives, my false positives, and my true positives. And you can calculate that out to understand, what is the dollar value of this model. Another great thing that it has is the description here. Sorry, the feature effects is what I was looking for. So this one also shows you your feature impact, the effects of each feature, and prediction explanations. And this one here I'm going to pause on is a huge benefit. The number one thing we hear from our call center that deals with escalations for someone who we've stopped for fraud is how do we understand why the system stopped it? And what DataRobot also allows you to do then is have these prediction explanations surfaced back with your API, and then where you can then label them and you can give your folks intuitive information about what led to stopping the order. And that may be things that they can tell the guests themselves, or maybe things that they use for their own evaluation. All right, so let's come back over here and see how we're doing. All right. So then what I did here was I simply went and did what's called a join function on the external data, and I'll jump back up to this and recreate it. If I can get it to cooperate. There we go. Well, I don't seem to be able to invoke the function. So the way you do a join is you click these 2 circles here, and you go in and select the data. And let's see if it already has it. And then it'll give you a preview of that. And then you can select the join keys. And what Trifacta will do is automatically detect which two keys appear like the ones you want to join, as well as anything else. And so what you can do is you can select everything there, and it will display it for you. Now I think I selected an errant one, so I'm going to cancel out of that. But I'd already did this. And what it did was it joined onto the end here these three additional fields that I added in to address validations and a distance from store field. So then I would run this job, create a new one, and then bring it into DataRobot and create yet another model set. So I can toggle over to that now. And here's the models that we built with the second one. So something I can run back to the data. So when I brought it in, DataRobot would have gone through and said, looked at each data field and come back and given me the means and standard deviations, an interpretation of the variable type, as well as it can create certain new data types that it detects. So in this case, at sale date, it realized that it can also create a categorical out of the day of the week. So it's very helpful in that way of exploring your data when you first import it, as well as making suggestions for you, or allowing you here to also create quick changes yourself. So in this one, on the order type, which was numeric, I changed that to a categorical and used that in the model building instead. So when you toggle back over to the models, same thing here. It went through and built a whole set of models here. I'm going to change this back over to log loss, or to AUC, and ranks them based on the outcomes, as well as gives you these tagging to say which ones it recommends. So in this case, the AVG blender was the one that I felt fit the best, but I can, again, compare it against these other ones. And if I toggle back and forth and look between these two, this was a 0.822 in AUC. If I toggle back to the first one, change this to AUC. This is a 0.8141. So improvement for sure with this data set. So what does that add up to, I think is part of the key question here, is you can then take those payoff matrices and calculate them out with your values and come out with this. And what this would tell me is over the course of this time span for this data set, this would have been a $300,000 improvement in its effectiveness. So that basically, that's where I can start the interpretation and the dialogue with a third-party vendor to say how valuable is their data set. And I've been able to do that really quickly by basically altering the my data flows, joining it together, drag and dropping it, and having DataRobot do its work. So I've taken what used to take several people and several days of work and a number of guessing to a certain degree, down to this entire process can be done in really less than a day. And at the end of this, if I have a model that I like, and you can go into deployment and deploy that model. So this one I had already clicked the button. But if let's say I had determined that I wanted to use the extreme gradient boost, you just come in here and you can use the deploy model, and I can add it to deployment. And what this does is this captures everything that you need to make the deployment, as well as who did it. So this ties in an entire level of compliance and regulatory oversight that you know who's making these changes, who's recommending it for deployment, and tracks the actual deployment metrics. And then it's a simple one-touch deploy, and DataRobot goes and does its thing. So at that point, you then have a couple choices in your actual deployment architecture. You can call an API to use this, or you can export the model into an object to use inside your own system. And those are both paths that Consensus is evaluating. So that was actually the 3 demos. And as I said, the payoff here is simply that and simply is the wrong way to put it. It's huge. We went from, like I said, multiple days, multiple people, into I can do this, or a number of folks on our team by themselves, a couple hours, a day at most. With DataRobot, and that's with Trifacta alone, that you're able to have a huge data prep savings in time, and I look at it as you're not trying to take somebody away from their day job. With DataRobot, we saw improvement in our model performance. I'm sorry, I forgot to thank you, David. We saw the improvement in model performance, a 24% gain in true positive detection, a 55% decrease in false positives, and a 19% gain in overall financial performance. And last but not least is I feel like this brings along the speed of curiosity, which is you can go through this whole process, evaluate new data sets, evaluate new models, and deploy, like I said, in less than a day, whereas this used to take weeks of combined effort. All right, and with that, we will move on to the Q&A.
Well, David, Harrison, Rajiv, hey, thank you for that excellent presentation. We'll get started with today's Q&A. Want to thank the audience for their participation. Had a lot of questions that have come in, and we'll do our best to get through all of them in the time remaining. So during the Q&A session, I'll leave up this screen with contact information for David, Harrison, and Rajiv if you'd like to contact them following today's webinar. So let's get started. Harrison, most of these are going to be for you, and we love the fact that you are a deeply involved user, and a lot of the questions have to do with what your experience was. For example, I presume that before you adopted Trifacta and DataRobot, that you were probably coding this stuff in Python or R. So the audience wants to know what your implementation experience was like. How long did it take? How long did it take to get from a raw start to being competent in all of this? Just tell us about your startup experience.
Yeah, so that part was fantastic. I mean, because they're both cloud-hosted SaaS solutions, getting the software up and usable is extremely quick turnaround from each company. I'd say a couple hours. Get your login and you're off and running. The training time is they're extremely intuitive to use. I mean, you can, if you want to, just start playing with them right away and figure your way through. The support is fantastic, though. Each company spent a lot of time and made themselves quite available to walk myself and my team through basic processes and concepts, and are available at almost every step of the way to reach out to and when you're stuck or you're trying to figure something out. So I'd say, for each application, within about a week, you're pretty competent at what you're doing. And within about a month, you're really moving along quickly, and I think then it's just a matter of repetition and an individual's ability to recall how to do things, if not write it down. In addition, DataRobot offers DataRobot University, which will give you in-depth training in a sort of all-day classroom. So yeah, worst case scenario, I'd say a couple weeks, your team should be working very well with these products.
Well, thanks for that insight. Now, tell us a little bit about your team and what skills are required to use these tools. Is everybody on your team a data scientist? Are there non-data scientists on your team using these tools? And what would you like to tell everybody else about the skills required to get started with these?
So the number one skill you need is that you just need to have a certain level of passion and domain expertise in the business, and really want to go get it. After that, it sort of solves itself. I mean, you have to have a certain level of technical and mathematical competency, but being a data scientist is in no way a requirement. That said, we do have a data scientist on staff, and part of why we went with this set of applications was to leverage her even more. and really hit that ability to use her in more of an advisory capacity, but get more people practicing data science, and then use her skills to oversee and guide people where they might have made mistakes, and give that sort of point of view to say if something is looking too good to be true, like, well, maybe we need to go back and look, do you have leakage, and what was your original data acquisition like? So as I said, the biggest benefit, I think, is breaking down the silos.
Well, that's really interesting about how you've been able to leverage, in your case, I think just one data scientist, but let's say a few data scientists relative to a much larger team of non-data scientists. What about the critical issue at the moment at which you put a new model into production? Does your data scientist sign off on that, or do you feel the tools are sufficiently competent to skip that?
So our practice will still be to have a data scientist sign off and give that blessing, and that's partly because it's necessary from a SOX compliance control process, but I also think it's very good practice. But I don't know that that's absolutely necessary for every business and every company. I think the key point would be, because the tools are so easy to use and the visibility is great, that you can just have a set of steps, say, hey, have a second set of eyes on this and sign off and keep moving. But even without that, the audit trail is always there. Anyone can go back and look at, well, how was that built, and who did it, and what steps were taken, and it's there for review. So I think it makes everyone just more comfortable with the approach.
Oh, terrific insights. Thank you. Now, there were a number of questions about what level of automation each of these tools has and how they work together. So, for example, where DataRobot appears to be pretty much fully automated, the audience was wondering how much automation is involved with Trifacta, because you need to know something about the application in order to clean and prep the data appropriately.
So I'll kick that over to David in a sec to touch on more. But in our case, because of the nature of the data we have and the way our current data architecture is built, we still need, when we are building these, to use data extracts and then do our data prep from that. But we also want to be able to do that using the data in its most, what I would call it, pristine state. However, I'll turn it over to David to answer about Trifacta's abilities to integrate directly to your data sources.
Yeah, so Bill, you mentioned that there's still some level of manual entry that's required within the Trifacta application. So especially with new projects and when you're first bringing in data for the first time, you will need to build the recipe. In that building process, however, Trifacta has a lot of machine learning and interactability within the product to help with those building of steps. Once those steps and those recipes have been built, Trifacta has a scheduler that you can use to automate already built flows containing various recipes within there. And those recipe objects are reusable once they've been created, so you can move them to other flows when new data sets come in. So there is a level of reusability there as well. And then, Harrison, your last point, just on the sources of data that are coming in. So we can connect to relational sources, cloud platforms, big data platforms, and wherever the data is coming from, you can connect and blend data from various sources, so you don't have to blend data from cloud to cloud. You can blend data from a cloud platform to an application, to a big data source, to a relational source, and so on. So as long as those data sets are being updated on the front end with new data and being refreshed, Trifacta can then pull that data and run it through a schedule to then push that output to where DataRobot can take it and run it through their models as well. Does that hopefully answer the question?
Oh, yeah, very much so. And it leads to the next audience question that I thought was really interesting. Now, Harrison, you described your product as one that could give literally instantaneous feedback to the retailer. And so the audience is wondering, okay, so the retailer's information streams into you, and this sounds like a streaming data application. And what does it do? Does it flow through a pre-existing Trifacta recipe and DataRobot recipe in order to issue an instant score? How do you get the response time down so low?
Right. So not the Trifacta recipe. That's not a production transformation process that we're using. So we build those natively in Java, and we use a combination of Storm and Spark for that. We then call the model, and as I said, we're exploring two different avenues there. DataRobot has a hosted prediction engine which you can use, and you can call that via API, and you get the response back, and the performance time there is great. Or, as I said, they also have an option called Cogen that you can import your model as a Java object and run that within your own system. They also have another way of using it that exports it as a proxy logistic regression. So any of those three options are available to you, and I'll kick it over to Rajiv to give you a little more pinpoint. But what I'm getting at is, worst case scenario, and it's a really good case, is you're calling out to DataRobot to give you your prediction. The rest of that is up to your own architecture, and as I said, that's where your IP lies, and that's the part that we love about this, is it allows us to focus our team on where we want to perform the most, and utilize somebody who does other things great to do their piece. Rajiv, do you want to take any part of that?
No, that was a great answer. DataRobot has a number of different ways for you to be able to serve out predictions, as you mentioned. We have a built-in prediction server that uses a REST API, or, as you also mentioned, a number of different ways to export your model in either Java or Python and be able to consume it that way as well. So, no, thank you.
Oh,
so one more thing, Bill, if I could bring it back, is but you know how Trifacta fits in that piece as well is it's having that ability to use Trifacta to build these recipes. Is you're basically building a prototype of that data transformation that you would need to build the model in the first place. So now, like I said, it allows a non-technical user to assemble the data as they see fit, and then turn this recipe, in a sense, over to a developer and say, okay, here's how I did it in Trifacta. Now let's figure out what's the best way and the fastest way to do this in our own code. And they have as a prototype that they know what the outcome should look like. So it really revs up your development cycles as well.
It's really a wonderful conversation about how you've utilized these tools and real-life examples of the challenges of implementation, and frankly, how easy it sounded. Probably a good time the audience is asking a pretty obvious question. Have you got trial versions, or how can they take a test run with both Trifacta and DataRobot?
So this is Rajiv with DataRobot. DataRobot is a software as a service. So if you're interested, reach out to our website, or you can reach out personally to me, and you can get contact through there that can help set you up to using DataRobot. Typically, we offer a free kind of proof of concept where you can test your data with DataRobot. All right, thanks.
And then on the Trifacta side, we do have a free SAS tool, which you can access at cloud.trifacta.com. There are some limitations compared to our paid products, but it's unlimited use in terms of there is no cap on the amount of time that you can use the product. So if you're looking to start transforming some data, it's a great place to start. And you can either access that through our website or, again, at cloud.trifacta.com.
Well, David, Harrison, Rajiv, thank you for some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to David, Harrison, and Rajiv and their respective teams so they can follow up with you after today's webinar. Now, I have just a couple of quick announcements. If you'd please mark your calendars for January 29th, that's our next DSC webinar, which will be Applying Convolutional Neural Networks with TensorFlow. Also remember that today's taping will be available on demand later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Also, all of our past webinars are available right there as well, and if you haven't had the opportunity to take a look, I encourage you to go through those. They provide some very useful insight into a wide variety of topics of interest to our data science community. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. A special thanks to Trifacta and DataRobot for their sponsorship, and particularly our speakers, David McNamara, Harrison Lynch, and Rajiv Shah, for their insight into today's topic. Well, this is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on January 29th. Have a great day.